In this video, I would like to describe different types of mutations, including the silent mutations, missense, nonsense, and the frameshift mutations. But first, I would like to describe the universal genetic code. So here we have the genetic code through which the mRNA can be translated into polypeptides. So every codon has 3 nucleotides which code for one specific amino acid. For instance, CU will correspond to proline, and so the codon CCU will give rise to proline. So just keep that in mind, that each codon only codes for one specific amino acids. And then at the same time, most amino acids are coded by multiple codons. So for the same proline, CCC, CCA, as well as CCG will also give rise to proline. So CCC, CCA, and CCG. So once again, each codon only specifies one amino acid, so CCU only codes for proline and no other amino acids, while every amino acid can be coded by more than one codon. CCC, CCA, and CCG are instances of the codons that code for the proline. And then one other important point that you should know is that most amino acids are coded by multiple codons, with the exception of the tryptophan and methionine. And methionine is AUG, or the start codon. And then the final point on this table is that the UGA, UAA, and UAG are all coding for the stop codon. So now let's go back to the table here. So protein synthesis starts at the initiation codon AUG, which codes for methionine, and then stop codons include UAA, UGA, and UAG. So for instance, in this mRNA, that's where the translation starts at the level of AUG, and then it will keep on reading every 3 nucleotide until it reaches the stop codon, which is UAA. Now with the silent mutations, the mutation does not affect the amino acid that the codon is coding for. So for instance, let's say that in this table we have a codon, for instance, for CCC, and then there is a mutation that changes the C into A. So CCA is still coding for proline, the same amino acid that the CCC was coding for that before. And this type of mutation is referred to as silent mutation. So silent mutations are usually seen with mutations in the 3rd nucleotide of a codon. And the 3rd nucleotide is usually referred to as a wobble position, because the 3rd nucleotide usually does not affect the code of the amino acid. For instance, let's see alanine as an example. GCU, GCC, GCA, and GGG all code for alanine. So it doesn't matter how you mutate these genes, the wobble position doesn't affect the code for the alanine. So that would be an example of silent mutations, where the mutation will result in the same amino acids and is often associated with the base change in the 3rd position of the codon. With the missense mutation, however, the amino acid changed. So let me give you an example. So let's say that we had the CAC. So we initially had CAC, which coded for histidine. But now we mutate that and code for something like CCC. So now we have CCC. So the A position has been mutated to CCC. And CCC is now coding for proline instead of histidine. And that would be an example of a missense mutation, where the amino acid has been changed. With the nonsense mutation, there is creation of an early stop codon. So the stop codons included UAA, UGA, and UAG. So let's say that in this mRNA example, let's say that we get a mutation of here, the G changes to A. So we get UGA right here, and that's a new stop codon. So our mRNA translation will now be stopped at here, and thus our polypeptide would be truncated. It would be 2 amino acids shorter than it should normally be. And that would be an example of nonsense mutation. And then finally, with the frameshift mutation, what happens is that there would be insertion or deletion of one or two nucleotides that will cause complete misreading of the entire nucleotides. So assume that there is either insertion or deletion of one nucleotide here. So let's say that the C is deleted, completely taken out. What happens is that the new reading code would be like this. So now there has been a complete frame shift and the entire sequences has been changed. And so this is referred to as frameshift mutation. Now in terms of severity, frameshift is the worst mutation that can develop. After that, nonsense, and then missense is less severe than nonsense, and finally silent, which is benign. And that concludes our discussion of different DNA mutations.